So hi guys, today I'm going to this video is going to be a summary for the chapter 5 entitled Ethernet. So this chapter it examines the characteristic and operations of Ethernet as it has evolved from the shared media contention based data communication technology to today's high bandwidth full duplex technology. So so the Ethernet encapsulation. For for the Ethernet encapsulation, Ethernet it is most widely used LAN technology today. Ethernet supports data bandwidth of 10 MBs, 100 MBs, 1000 MBs, 10,000 MBs, 4000 MBs, and 100,000 MBs. So there ha there are two Ethernet MAC sublayer primary responsibilities, which is the data encapsulation and media access control. So, for the data encapsulation, the data encapsulation process includes the frame assembled before transmissions and frame disassembled upon receptions of frame. So, data encapsulations provide three primary functions, which is the frame delimiting. The framing process provides important delimiters that are used to identify a group of bits that made up a frame. Delimiting bits provide synchronizations between the transmitting and receiving nodes. So for the addressing, the encapsulations process contains the layer 3 PDU and also provides for data link layer addressings and error detection. So for each frame contains a layer uses to detect any errors in transmissions. So also the media access control. So the second responsibility of the MAC sublayer is media access control. So the media access control is responsible for the replacement of the frame on the media and the removal of frame from the media. So also Ethernet evolution. So since the creation of Ethernet in 1973, standards have evolved from specifying faster and more flexible version of the technology. So each version of Ethernet were relatively slow at 10 Mbps. So the latest version of Ethernet operates at 10 gigabits per second and faster. So also Ethernet frame fields. So in the minimum Ethernet frame field size is 64 bytes and the maximum of 1518 bytes. So this includes all bytes from the destination MAC address field through the frame check sequence or the FCS field. So the reassembled field is not included when describing the size of film. So for the LAN switches, the switch fundamentals. Um, the unlike the legacy Ethernet hubs that repeat bits out of all ports except the incoming ports, so an Ethernet switch consists a MAC address table to make a forwarding decision for each time. So in the future, um, in, so in the so it has not yet learned the MAC address for the four attached PC. So note that the MAC address is sometimes referred to as content, um, addressable memory or CAM table, while the term CAM or CAM table is fairly common for purpose of this course, so we will refer it as MAC address table. And also, um, the filtering frames. So, as switch receive frame from different devices, it is able to populate its MAC address table by examining the source MAC address of every frame. So, when a device has an IP address that is not on a remote network, the Ethernet frame cannot be sent directly to the destination device. Um, and for the address resolution protocol, so for the address resolution protocol, so there are two primary addresses assigned to device in a on a Ethernet LAN. So the first one is the physical address, which is the MAC address used for Ethernet NIC to Ethernet NIC communication on the same network. So the logical address is the IP address used. So the IP address used to send the packet from the original source to destination. So most application use DNS or the domain name system to determine the IP address when given a domain name such as www.cisco.com. So DNS is discussed in later, and I will discuss the DNA maybe on the later chapter. Also, the destination remote network. So when the destination IP address is a remote network, the destination MAC address will be the address of the host default gateway. So, so recall that every time with IP address on an Ethernet network also has an Ethernet MAC attends when a when a device sends an Ethernet frame, it contains two address. So the first address is destination MAC address, which is the MAC address of the Ethernet NIC, which will be either the MAC address of the final destination device or a router, and the source MAC address, which is the MAC address of the sender Ethernet NIC. So ARP message are encapsulated directly within an Ethernet frame. So there are also no IPv4 header. So the IPv4 is request message. The IP request message includes. So the target IPv4 address. So this is the IPv4 addresses that requires a corresponding MAC address, and for the target MAC address, this is the unknown MAC address and will be entered in the ARP request message. Also, we have um, the ARP request is encapsulated in an Ethernet frame using the following header information. So the following header is the destination MAC address, source MAC address, and the type MAC address. So, the destination, this is a broadcast address acquiring all Ethernet NICs on the LAN to accept the process of the ARP request. For the source address, is the sender of the ARP request MAC address, and for the type, the ARP message have a type field of 0x08 to inform the receiving NIC that the data portion of the frame needs to pass to the ARP process. So yeah, most of Ethernet networks and end device are technically connected on point-to-point basis. So a layer 2 switch buildings a MAC address table that is used to make forwarding decisions. So layer 2 switches depends on router to pass between independent IP networks. So that's all again for the chapter 5 summary of the chapter 5. Thank you guys again for watching.